Okay, so now we are on section 3 of geometry, which is postulates. We just went over in this previous slide 3 of the important postulates that will be in this section, section 3. And so we're going to go through a series of example problems that use those postulates to help us with the example problems. Okay, so let's start with example A. Okay, so for example A, the first part of it says that Q, R, S, T are non-collinear points, which means that they do not lie on the same line, and that's because all of them are not on the same line. Non-collinear means not on the same line. Okay, and the second part of it says, name all of the lines that can be drawn through these different points. Okay, and so I'm just going to go ahead and draw the 3 lines. So we have our first line that can be drawn through point Q and point T. So we have line okay, and hopefully you can see this pretty clearly. It says QT, and it has a line with continuous arrows on the end of it. So we have line QT, that's 1. Then we have line T, line TS that goes through the points T and S. So then we have line TS. Then we have line SR, which go through the points of S and R. So we have line SR, and notice that each one of these have the line with the continuous arrows on the end. And our last one is line QR. It goes through the points Q and R, and so we can put QR for our last line. And so that's for A. The postulate that this one uses is that 2 points determine a distinct line, and so that means that with any 2 points you can draw only one line between those 2 points. And so that postulate helped us determine that with all of these 4 points we could draw 4 distinct lines. Okay? Let's look at example problem B that also uses this picture. Okay, B says, name the intersection of QR and RS. So if we look at QR, it goes here, and if we look at RS, it goes here. And so their intersection is right here at point R. So our answer for B is simply point R. The line Q and R and S and R go exactly through that one point. Okay? And the postulate that helps us with that one is 1-2, postulate 1-2. It's that if 2 distinct lines intersect, then their intersection is at a point. And so in this case, the 2 lines that they're referring to are Q and R and S, and those 2 lines intersect right at point R. Okay? Let's look at example 3. C. Okay, so for example C, it says, name all of the planes that are represented in the figure. And this figure is the figure that they show here. So we're going to use the third postulate that says that 3 non-collinear points determine any one plane. And we're going to write all of the planes that we see in this picture. Okay? So if we look at the top of this shape, we can see that A, B, and C make this triangle right here, which is a plane. So our first plane is plane A, B, C. And we can just write it like a little triangle, or you can just write plane A, B, C. The next one that I noticed is these 4 points here, and it's C, B, E, F. And remember, when you're writing a plane, you want to make sure that the numbers are the letters are in order of how you want them to be read. So we don't want to do C, E, B, F because they're diagonal from each other. We want to go in order. So we want to go C, B, E, F. You could also represent it starting with another point, so like E, F, C, B, but you just want to make sure that they're all written in order. So I'm just going to simply write C, B, E, F. So the second one. So the second plane will be plane C, B, E, F. Okay, and then they ask us for all of them. So we have the top plane, the side plane, and now we have also this side plane. So I'm going to label this one F, C, A, D for the side. So this one is plane F, C, A, D. F, C, A, D. You can also put them, like I said, starting with a different point, but as long as you keep them in order, okay? And so the final plane that I see is just this one down on the bottom, and so we have plane D, E, F.